Let's look now at a middle school science class in Jacksonville, Florida. The teacher, Scott Sowell, wants his students to understand Bernoulli's law, the principle that explains how airplanes are able to fly. As you watch, compare what you're seeing to what you remember about the kindergarten class in the first segment.
Keep that idea in your mind. Keep that a force is a push or a pull, and also keep in your mind that objects move in the direction of the greatest force. Where's the greater force? Below it or above it? Okay. Okay, I want each person to take their paper and hold it like this. Hold it like this. Can everyone see what? Don't hold it like this. With 2 fingers, hold it like this. With a long edge going this way, towards the top, Delonzo. Towards the top. Now, with a big breath, I want you to do what I do, but watch me first and watch what happens. Go ahead and try that and look what happens. I'm blowing on the top. A lot of hot air. A lot of hot air. Okay? Mr. Lynch. Shh. Okay, let's stop blowing. Tell me what happened when we blew across the top of the paper. The paper moved. How did the paper move? Okay, do it again. I want the one person I call on to answer. Do it again. Take the straw out of your mouth. Put it on the desk. How did that paper just move just then? Straight. Do it again. Blow hard. What did the paper do?
It came up.
It came up. It came up. When you blow across, it comes up. The next thing I want you to do, and only 2 people at the table will be able to do this at one time, but I want one person on each side of the table to take 2 of the sheets and hold them just by the very tips of your fingers down like this, not touching. Wait, eyeballs on me. Don't start yet. Eyeballs on me. Ladies, hang the papers down slowly or lowly, and then blow in between them. And watch what happens. Let's look at one more. What you're going to do, well, I'll do it first up here, and I want you to watch. Watch what I do up here. Leave the equipment alone for a minute, and eyeballs up here. Now, have a funnel and a ping pong ball. Watch what happens. When I blow into this funnel, I'm going to shoot Tristan in the head with the ping pong ball when I blow. You ready, Tristan? So, the ping pong ball didn't fly out, did it? It did just the opposite.
Because the air has to go on a circular motion because of the air.
Let's look at these. Let's take a look. Number 1, the first one. The first one we had a piece of paper like this. Is that correct? We had a piece of paper. And where was I blowing? Was I blowing on the top or the bottom, Rachel? I'm going to ask one person, okay? Thank you guys, that was right. I was asking which direction do we blow? Do we blow on top of the paper or under the paper? On top. And what did we see happen there, Heather?
When you go on top, made the paper go up.
Made it go up. So we had the paper actually moved up, didn't it? Okay, it rose up. That was number 1. Number 2, we had 2 pieces of paper like this. And what did we do to those sheets, Shantae? What did we do to those 2 pieces of paper? Blew into the top, didn't we? We blew down into there. And what happened there, Ricky? What happened to those papers when we blew into them? They came together, didn't they? Good. So we saw this paper rise up. These 2 papers come together. And then this final one, number 3, number 3, what did we do there, Mr. Lynch? What did we do to that one? We blew into the funnel, and what did we see happen? Abe, what did we see happen? The ball didn't come out, did it? It stayed right there. Okay? The ball stayed right there. It didn't go anywhere. Just kind of stayed right there. And didn't it kind of move around and shake around a little bit? But it stayed right there. Okay? Let's think about some forces that might be acting on these. Let's think about the paper now. What are some forces that are acting on the paper? Colin? Wind. Okay, we have the wind here. Now, what's another force? Gravity. Which direction is gravity pulling this? Down. So we have a force going down. We have a force going down. Is there a force pushing up, William? How do you know that there's a force pushing it up? Exactly. You know there's a force pushing it up because it moved up. Things don't move without a force. Okay? So William said there's actually a force. Actually, let's draw this here. We've got gravity pulling down, and we've got a force pushing up. Let's label this A and this B. Now let's move over here. Where was there a force? Pushing on the inside. That's exactly right. Because if they move that way, you've got to have a force that way, don't they? Okay? Now let's go here. What's a force acting on that ball? The wind. You've got a wind, and which direction is that force? Is it this way or this way?
That way.
To the right or to the left?
The right.
To the right. So you've got a force acting on it this way. Okay, let's label that A. Okay? There's another force from the air, and we'll label that B. Now, let's look at some trends as to why. Everybody pay attention. Number one, which one did we say was greater, A or B?
B.
B. So let's get rid of, well, we'll just keep this one on here. So we said that B was the greatest force. Which one in number two, A or B?
A.
A, good. And what about number three, A or B?
B.
B. Okay? Now, I want everybody to look closely. Look closely. Where do you see, or do you see a relationship between where you blew and which one was stronger? Heather.
It seems like every time you blew on that certain spot, you thought it would go the opposite direction.
Okay. But what actually happened?
It went in the opposite direction of where you
Okay.
thought it would.
Okay, so if it goes in the opposite direction, what does that mean about the force on that direction?
It's greater.
It's greater. So every place you blew, where was the force greater?
On the opposite.
On the opposite side. So this guy named Bernoulli's law, he thought this up, or he discovered this. He said that every time you increase the speed of the wind, the force goes down. So when I speed up the wind on top of the paper, the force here goes down, this force takes over. Same thing between two sheets. When I blow in here, the force pushing them apart goes down, then the outside force takes over.